Okay, ma'am. The human beings have the ability to alter the stroke volume, especially in athletes, in sports persons. In sports persons, especially sports persons have the ability to alter the stroke volume as well as heart rate, thereby cardiac output. Yes, when we were in normal condition, our heartbeat is normal. When we were in active condition, when we are playing vigorously, at that time our heart rate is increased. That is only, especially in athletes or sports persons. Okay, the stroke volume, heart rate, thereby cardiac output can be changed according to the situation. If they are vigorously playing, the heart rate is rising, stroke volume is rising. If they are in normal condition, not only sports person, even we also, if you are in normal condition, our heart rate is normal condition. If we are in active state, heart rate is rising. It is normal. Okay, that's it. Next, double circulation. Next, double circulation. So about double circulation, already I said that in human body, the circulation occurs in doubles, twice. Therefore, it is called double circulatory heart, double circulation. That movement is same. But also now again I will say because the specific topic. So in this one, first one is pulmonary circulation. Pulmonary circulation. Circulation. And we know the things. So see here. See here, right auricle, right ventricle, left auricle, left ventricle. It is not stable. So right auricle receives deoxygenated blood through right auriculoventricular aperture. Deoxygenated blood enters into the right ventricle. From the right ventricle, the blood is entering into the pulmonary artery or our pulmonary arch. So the deoxygenated blood enters into the pulmonary artery. So outside of the heart, the pulmonary artery is divided into two branches. It is left, it is right pulmonary artery, right pulmonary artery. It is left pulmonary artery. Left pulmonary artery. This left pulmonary artery is connected to the left lung. Right pulmonary artery is connected to the right lung. Left lung. Already I said that. Okay, so deoxygenated blood from right ventricle entered into the pulmonary artery. So through pulmonary artery, deoxygenated passed through right pulmonary artery into the right lung. Through left pulmonary artery, it goes to the left lung. In the lungs, deoxygenated blood becomes oxygenated. So from the lungs, pulmonary vein carries oxygenated blood, and sent to the left auricle. This is called pulmonary circulation. As you studied that, it is already below in classes. Pulmonary circulation. Here one point you have to remember. The pulmonary artery, it is pulmonary artery or pulmonary aorta, pulmonary trunk or pulmonary arch. It is the main like this. After the heart, it is divided into two arteries, left artery, right artery. Okay, so that's it. So in the lungs, deoxygenated blood becomes oxygenated. After that, pulmonary vein takes that oxygenated blood and send them to the heart, especially, particularly in left auricle. This is called pulmonary circulation. Pulmonary circulation. So next, systemic circulation. So why we are calling pulmonary circulation? This is called pulmonary artery, pulmonary aorta, pulmonary arch, pulmonary trunk. All are same synonyms. That is why it is called pulmonary circulation. Next one is systemic circulation. What happens? Pulmonary vein carries oxygenated blood and sent into the left auricle. So oxygenated blood from the left auricle enters into the left ventricle through left auriculoventricular aperture. Left auriculoventricular aperture. And finally entered into the left ventricle. From the left ventricle, one more aorta, that is systemic aorta, systemic arch, systemic trunk, all are same synonyms. Which name you can comfort, that you can write correctly. Systemic trunk, systemic aorta, systemic arch, arises from the left ventricle. So here the oxygenated blood already there. But oxygenated blood entered into the systemic trunk. Systemic trunk. It is systemic aorta. Outside of the heart, systemic aorta is divided into artery. This artery divided into arterioles. Arterioles is converted into capillaries. Come to the point. Aorta, arteries, arterioles, capillaries to the tissues. See, from the left ventricle, oxygenated blood entered into the systemic aorta. This systemic aorta outside of the heart is converted into arteries. Arteries is divided into arterioles. Arterioles is converted into capillaries. These capillaries supply blood to all the tissues throughout our body. All the tissues throughout our body. Okay, so from the tissues. So through this oxygen gets to almost all the body tissues. All the tissues utilize oxygenated blood and release. So sent to the right auricle, sent to the heart. In the heart, especially right auricle. This is called systemic circulation. This is called systemic circulation. See here, aorta, from aorta to arterioles, arterioles to arteries, arteries to arterioles, arterioles to capillaries, capillaries to tissues. This is main artery, aorta. This is main aorta. Next, artery. Same like here. Please note. Like this way. These are artery. Aorta, artery, arterioles. Next, these are all capillaries. Capillaries. Capillaries too. Oxygenated blood passes to the tissues. In the tissues, every tissue utilises oxygenated blood and releases this deoxygenated blood from the tissues. From the tissues. System of venules. Venules means what? Smaller blood vessels. Number of smaller blood vessels collectively called smaller blood vessels collects deoxygenated blood and sent into the large vein. Vena cava, inferior vena cava, however it is there. These are all collects the oxygenated blood and sent into the right arm. This is called systemic circulation. The systemic circulation supplies oxygen, nutrients, and other essential substances to all body parts, and collects waste materials and selectively eliminated them through kidney and purify through heart, through lungs. Some waste materials are sent to the kidneys. In the kidney, those are filtered and sent out. Deoxygenated blood, some amount comes to the other waste materials that goes to kidney. Some amount of blood goes to heart. From heart, it goes to lungs for purification. Okay, so this is called systemic circulation. So that is why human heart is called double circuit circulation. Double circuit circulatory heart. Okay, that's it. Okay. Next topic, portal system. And coronary circulation. First of all, let us see portal system. Portal system. Portal system. So, the blood vessel ends with capillaries and starts with capillaries. That is called portal system. The blood vessels starts with the capillaries and ends with the capillaries. Okay, arteries starts with the capillaries, ends with the vein. Arteries starts with the capillaries, ends with the capillaries. That is called portal system. Okay. So that is portal system. The blood vessels starts with the capillaries and ends with the capillaries. That is called portal system. In human beings, there is a portal system is present. In man, there is a portal system is present. In between digestive tract and liver. That is called hepatic portal. Hepatic portal. Hepatic portal system. Okay, in man, there is a special portal system. Portal, luggage portal. You might have heard in bus stands, railway station, luggage portal. Like that in our body. Portal system. That portal system carries some substances from one place to another place. That is why it is called portal system. In man, there is a portal system between digestive tract and the liver. That is called hepatic portal system. So this portal system carries some substances from the gut to the from the gut to the liver. Before it is entered into the heart. Before entering into the heart, first it goes to the liver. From the heart, after it goes to the, from the liver, it goes to the heart. That is called hepatic portal system. Okay, so in man there is a special portal system that is called hepatic portal system, which carries some substances, digestive substances, sugars, amino acids, proteins, etc. Digestive substances from digestive tract to the liver. Thereafter, from the liver it goes to the heart. That system is called hepatic portal system. So the absorbed substances, in those absorbed substances, if sugars, glucose content is more and more, that excess glucose is converted into glycogen. Excess glucose is converted into glucose. Excess glucose is converted into glycogen. Excess glucose is converted into glycogen, which is stored in liver. This is called glycogenesis. One mark definition. Define glycogenesis. From the absorbed substances, excess amount of sugars and glucose, the excess glucose is converted into glycogen in presence of glucagon hormone. Excess glucose is converted into glycogen in presence of glucagon hormone and stored in liver. This phenomenon is called glycogenesis. Glycogenesis means conversion of glucose into glycogen in presence of glucagon hormone. Okay, this is called portal. So any blood vessel starts with capillaries, network-like structures, capillaries. Any blood vessel starts with capillaries and ends with the capillaries. That is called portal system. The effective portal system in human beings is hepatic portal system. This hepatic portal system carries digestive substances from the digestive tract to the liver before it is entered into the heart. In the liver, from the absorbed substances, excess glucose is converted into glycogen in presence of glucagon hormone and stored this glycogen in. This phenomenon is called glycogenesis. This phenomenon is called glycogenesis. Next topic, coronary circulation. So, coronary circulation mainly involved with the help of two blood vessels. One is coronary artery. So, coronary artery, it carries deoxygenated blood. Oxygenated blood. Coronary artery carries oxygenated blood. From the heart to the muscles around the heart, cardiac muscles are present. Coronary artery carries oxygenated blood from heart to the musculature. So whereas coronary ring carries Deoxygenated blood from the medulla of the heart to the right auricle, right auricle or atrium, right atrium. This phenomenon, this process is called coronary circulation. Cardiac activity. Next topic is regulation of cardiac activity. So, special neural center in the medulla oblongata of the brain. A special neural center in the medulla oblongata of the brain can regulate the cardiac activity through autonomous nervous system. Autonomous nervous system. Special neural center in the medulla oblongata of the brain regulate the cardiac activity through autonomous nervous system. That is one statement. Next, neural signals from the sympathetic nervous system. Neural signals through sympathetic neural signals through sympathetic nervous system can increase the heart rate, can increase the heart rate, strength of ventricles. Okay, neural signals, special neural signals from the sympathetic nervous system can increase the heart rate, ventricular contraction, thereby cardiac output, special neural signals from the sympathetic nervous system can increase the heart rate, thereby ventricular contraction is increased, thereby cardiac output is increased. In such cases, special neural signals through parasympathetic nervous system can decrease heart rate. The strength of ventricular contraction. Thereby cardiac output. So special adrenal medullary hormones such as epinephrine, norepinephrine can increase the heart rate. Not only these, medullary hormones. Our topic is not about adrenal gland. To explain about the complete adrenal gland. Next lesson I will explain. Special type of hormones from the adrenal medullary gland, that is epinephrine and norepinephrine, can also increase the rate of heartbeat. Thyroxine hormone. Thyroxine hormone is secreted by the thyroid gland. Thyroxine also can increase the rate of heartbeat. So this increasing, decreasing is essential to our body. When our heartbeat is increasing, at that time immediately another center from the brain can regulate. This regulation is important. Should not get it less, should not get it rise. If it gets less, it is dangerous to low BP. If it is raised, high blood pressure. Both should be regulated properly. That could be done by our nervous system. A special neural center present in the middle oblongate of the brain can regulate the cardiac activity, and maintain optimal functioning of our heart. If that neural signals are failed, some conditions, some people will face lower blood pressure. Some people will face higher blood pressure. Okay, so this is called regulation of cardiac activity.